Continuing on with our similar right triangles work, if we have a right triangle that is generated from a square, so in other words, a right triangle that comes from the diagonal of a square, cutting off that square such that we only have half of it remaining. That has some certain characteristics to it that are going to make it easy to solve. Now, the title of this thing is actually 45, 45, 90. But if you look at this triangle with two 45-degree angles and a right angle, that's clearly an isosceles triangle because of the two equal angles. And so that tells me that these two equal sides are going to be there as well. And again, it comes from cutting a square in half, so that's another reason why those two sides are equal. So if I know one, I know the other. And so each of those legs in this case are unknown, so they're both x. Now, in order to get the hypotenuse, it's going to come out to x root 2, and that will always be the case, because if I write down Pythagorean theorem here, I would have x squared plus x squared equals c squared. And so that's 2x squared equals c squared. And so when I do the square root, I get root 2 and I get x. So whatever that original side length was, the hypotenuse will have that number in it as well, with a root 2 on the end of it. And that will just be a really nice and easy shortcut that we can use to generate the hypotenuse of any 45-degree right triangle. All right, so to go through a couple of examples here, it'd be worthwhile, I think, for you to try some of these before they get revealed. But just know that the fundamental of this is if we are trying to solve for one of the legs in a 45-degree triangle, all we need to do is repeat the other leg because it is isosceles. And then if we want the hypotenuse, all we're going to do is attach a root 2. And so that's what number 1 is about. For number 2, same kind of thing. Exactly the same thing, except I'm solving for y first. And then number 3, we'll talk about that one in just a second. So give the first two a try, and then we'll see how you did. Okay, so for number 1, I want to make sure that I'm repeating the leg for x, and that I'm attaching a root 2 for y. And number 2, the same thing. I'm repeating the 25 for x, and attaching a root 2 for y, and then attaching a root 2 for x. So both of those hypotenuses contain the same number that the leg did, just attaching a root 2 to it. And then for number 3, so this time I'm going the other direction. So instead of multiplying by root 2, because I know the hypotenuse, I'm actually going to have to divide by root 2. And that's going to require one extra step. And that extra step is called rationalizing the denominator. So anytime you have a root on the bottom, process is multiply the numerator and the denominator by that root. So you would have 19 root 2 on top. You'd have root 2 times root 2 on the bottom, which is root 4. And so that solves out to a 2. So what that does is it makes my denominator no longer have an irrational number in it. So anytime you divide by a root, that's a step that needs to be taken. So to generalize these, if you know the legs, you multiply by root 2 to get to the hypotenuse, because it's bigger. And if you know the hypotenuse, you divide by root 2 to get to the legs because they're smaller. All right, so now if we were to have a 40, instead of a square, a little trouble with my controls here. Bear with me just a second. Okay, I think we've got it now. All right, so if I were to start with an equilateral triangle, so starting with a triangle that has 60-degree angles on all three sides. Let me just quick draw one here. I have an equilateral triangle, and I take that triangle and I split it right down the middle. That top angle, which was 60 degrees, is now 30 and 30. Okay, and if I split it correctly right down the middle, I'm going to have a right angle at the bottom as well. So this 30, 60, 90 triangle is essentially half of an equilateral triangle. Okay, I've just cut it right down the center, and that's what I ended up with. So let's just imagine that the bottom of that triangle is a number that we don't know. So we're going to call it x. Could be any number you want. So that's this side down here. Because I generated that segment by cutting an equilateral triangle in half, what that tells me is that there would have been another one over on the other side that I eliminated. And so each full side of this triangle is going to be twice as long as what I still have on this base. So that's where this 2x comes from. Okay, so that side is twice as long as the base because this base is half of the triangle. So I have an x, I have a 2x. Maybe I'll have a 4 and an 8, or maybe I'll have a 10 and a 20. Just they'll be double, okay? So then to get that third side that's standing vertically, again, it's Pythagorean theorem. I'm going to say x squared plus b squared equals 2x squared. Well, 2x squared is 4. If I square the whole thing, it becomes 4x squared. And so if I subtract 4x squared minus 1x squared, I get 3x squared. And so the square root of that gives me root 3 and an x. So the shortcut to this is if I know the short leg, I'm simply going to attach a root 3 to it. And that's going to make it bigger because root 3 is more than 1. So that makes sense because it's the longer leg. So if I start with the short leg, the one across from the smaller angle, I'm going to multiply by root 3 to get to the long leg. If I want to get from the short leg to the hypotenuse, it's even easier. I'm just going to double it because, again, it's half of that triangle. And if I want to go the other direction, since the hypotenuse is longer, I can get to the short leg by cutting in half. And if I want to get from the vertical leg to the short leg, I can just divide by root 3 instead of multiplying. What we're never going to do is go directly between the short leg and the hypotenuse because there isn't a common factor between them. So everything's going to anchor back to the short leg. It's either going to go this direction or it's going to go this direction. So that side across from the 30, that's the key. Okay, so as we try to solve some of these, let's take a look at number 4. Number 4's got a 5, and it's in the short side position. And the reason I know that is because I have a 60-degree angle here, which would put a 30-degree angle at the top. Well, 30 degrees at the top, go straight across, that makes 5 the short side. Not because it looks like the short side, but because it's across from the smallest angle. So if I know the short side, remember what happens. I'm going to double to get to the hypotenuse, so y is going to equal 10. I'm going to put a root 3 on it to get to the long leg. All right, so it's going to be 5 root 3 here. It's going to be 10 here. All right, so that's the first one. On the second one, the 30-degree angle has been located here, and so that 14 is in fact the shortest side in the triangle. So if I double it, then I'll complete the whole triangle. So x is that hypotenuse, x is going to be 28. And if I just attach a root 3 to it, then I can get the y value, be 14 root 3. All right, now for number 6, I know the longest side this time, the one across from the 90. So again, I don't want to go directly to the long leg. I want to go to the short leg and then around to the long leg. So if I take that 32, I can get to this half side by dividing by 2. So x is going to be 16. Then to get to the y from there, remember it's just attaching a root 3 to it. So if I know this is 16 now, then this is 16 root 3. And I have that. Okay, so try to go from the short to the 2 long ones. If you don't know the short one, get it first and then get the long ones from there. All right, let's look at these other 2, this last row of 3 as well. I'm going to take this one at a time even though I'm showing you all 3 at once. So in number 7, I've got my 60-degree angle, which means my 30 would be over here. I want to go to the short side first, which is y. So look at the 46, it's in the hypotenuse position. And so dividing by 2 gives me 23 for y. Once I've got 23 there, I can simply move around the triangle and attach a root 3 to it. So the x is 23 root 3. Number 8's a tricky one because the side that I know is the 60-degree side, which is the middle side. That's the one that would have had a root 3 attached to it. So to get back to the short side, I need to divide by root 3. Remember, I never want to go directly to the hypotenuse from here, from that middle side. I want to go to the short side first, and then I'll go around here. So I divide by root 3. That step of rationalizing the denominator has happened here. I'm multiplying top and bottom by root 3. So there's 20 root 3 on top. There would have been root 9 on the bottom, which solves to 3. And once I have that, then that represents the short side. Now I can double. So 20 root 3 over 3 becomes 40 root 3 over 3 if I multiply by 2. Okay, so that's the trickiest kind, is when you know that middle length. You want to divide by root 3 first and then double. And that happens again in number 9, although the math is a little easier because I'm starting, so there's the 30, right? So that means the 60 is over here. That 9 root 3 is in the 60-degree position, which makes it the middle side. So I need to divide that by root 3, which just takes out the root 3, leaves me with 9 for x, and at that point then I can double and get 18. Okay, so we'll practice with this several times during class. Hopefully that made mostly sense, and we'll work with it some more.